I just want to start with a little bit of a revision of the last lesson. So can you tell me, maybe somebody can come online and tell me, what do they remember from the last lesson? What's stuck around in your head from the last lesson? I'm interested to know what you remember. Maybe put your hand up if you're willing to share, or put it in the chat. What stands out from the last time that we were together? Any ideas? So I remember us finding the x-intercepts and the y-intercepts, but of what? Oh, straight line equation. There we go. That also. What else? Let's go to Andiswanene. Hello.
Hi.
What do you remember?
So last week we learned about the forms of the equation of a parabola, the turning point, the root form, the standard form, and we also learned how to find the y-intercepts and the x-intercepts.
Yes. So we spoke about the parabola. I'm not sure if I actually drew this, but this is called the standard form of a parabola. And I gave you some examples. And then I didn't actually draw this, but we're going to talk a little bit about it today. What's called the turning point form of a parabola. And so the parabola has two forms. We mainly spoke about quite simple looking parabolas like that or like that. And so yeah, that was kind of the last lesson. Yeah. Cool. All right. Well, I think it's time that we progress on to today's lesson. So the first thing is I just want to mention that, well, I'll do it again. The parabola that we spoke about last time is great, but the main type of parabola you encounter in grade 11 is something called the parabola in standard form. And so that's an example of what it looks like in the general form. In a specific form, it might look, say, something like that. And then there's another way of writing a parabola, which we call the turning point form. And it looks a bit like that. And an example, a real life example, might be something like that. Give me a thumbs up if you feel like you recognize this information about parabolas. Give me a thumbs down if that looks totally foreign to you. Okay. Now, it looks like for the most part, people are recognizing the different types of parabolas. Now, one of the things we want to be able to do, we want to be able to go at a later stage, we want to be able to go between these two different forms, because these two different forms can actually be changed from standard to turning point and back again. But we'll talk about that later. But I just want to make you aware that these can be changed from one form to the other. Okay, so let's have a look at a simple example of how we get these funny looking in the turning point form. We have these funny letters A, P, and Q. And I want to show you what they actually do. So if you have something like y equals x squared, then the A value is 1. What do you think is going to happen if I change the value in front of that to a 2? Who would like to come online and tell me, what do you think, that what effect is this 2 going to have on the shape of the graph over here? Who has any ideas what it's almost like it's going to move up. I don't know if it's going to move up, because shifting up is actually got to do with this thing over here. What does this A value going to do? I think that, yeah, Amachle, let's go to you. What do you think is going to happen here?
From what I understand, hi, sir, sorry, hi.
Hello.
From what I understand that you told us, I think that it's gonna do a vertical shift.
Okay, it's not going to quite be a vertical shift. It's going to be steeper. It's almost like the smile lines get even steeper. So if the number in front is a 2 or a 3, it's almost like the whole thing, it goes from a wide smile to sort of a narrow smile like that. Okay.
Oh, yeah.
That's the number in front of the x squared, or if we're looking at the turning point form, it's going to be this value. An example would be like if I said to you, y equals 3x squared, that would be even steeper, and that would look like that. So it's almost like someone's face is being pulled up. So that's the first, we talk about it like the A value making the graph happy or sad. And as the A value gets bigger, it makes the graph even more happy, basically. It's kind of getting steeper. Okay.
So if it's a negative, does it go down?
If it's a negative, yeah. So if it was y equals minus x squared, it would be an unhappy graph like that.
Oh, okay.
And yeah, that's a good observation. So we're going to learn a lot about that today. Now, the next thing I want to talk about is if I have, let's say I have, you know what, actually, instead of me going into too much detail, I think what I should do is I should do an example of how we draw a graph, and then you guys can mimic what I'm drawing, and we'll learn more like that. So I'm going to talk a little bit more about what the P and the Q do, but I'm just going to tell you for now, the Q, this would be a vertical shift. So it shifts the graph up or down. And this one here is a horizontal shift. Okay, so what that's going to do is it's going to move the basic graph left and right. And then the A value is just basically how steep the graph is, or how steep the smile is, how much its arms point upwards. And so those are 3 variables that we need to be aware of in the turning point form. But I think if I go into too much detail here, it's going to be confusing. So I'd rather actually show you an example of how we might do this process. Okay, I'll give you a moment. If you want to take a screenshot of this, you can. But I'm actually going to move now to a process of drawing a parabola. So this parabola is in standard form. I think I'm rather going to get one that is in turning point form to do with you first. So let me go and get this one. Okay. Actually, you know what? Let me rather draw a line. Let me start with the standard form one. So in order to draw a parabola, it's a 5-step process. We look at the graph. Is it a parabola? Yes. Boma, what's your question before we get going?
So I don't have a question. I'm just saying that the screen, I can't see the screen.
Okay. If you speak to Lebo in the chat, I'm sure we'll sort you out there. Cool. All right. So if we look at this number in front, this number is negative. And what that means to me is that this is an unhappy graph. And this tells me the shape of the parabola. Then step 2 is you're going to find the y-intercept. And step 3, we're going to find the x-intercept. Now, using what we know about the y-intercept, whenever we find the y-intercept, we make x naught. And so the y-intercept here would be 20. Give me a thumbs up if you understand why the y-intercept is 20 for this parabola. Give me a thumbs up if you understand why that is. Okay. Now, if you want to find the x-intercept, we need to make y naught. And so we have to solve this equation. Now, I want you guys to find me x-intercepts, or which are the solution to this equation. I want you to take a moment to do it and then put your answers in the chat. Now, there's a couple of ways you can do it. I suspect most of you would use the formula, but I want to give you a chance to do it and then put your answers into the chat for the x-intercepts. That is the quadratic formula that you can use. Don't worry, Boitimelo, hang in there. You're going to see, I'm just doing an example now, and then you're going to practice after me. So we get what are my answers going to be for my x-intercepts here? So RT has put an answer in. Who agrees? So with your calculators, you can go -8 plus square root of 2224 divided by -4. Okay, so we get 5.74, or x is -1.74. Okay, nicely done, everyone. Now, we're not done yet. There's only 2 more steps to do. Now, when you have a parabola, one of the things that is interesting about a parabola, and this is going to be a negative one, I don't know where it is, but I'm just going to make an example, is that a parabola has an axis of symmetry. There's a part where it gets cut in half, what we call the axis of symmetry. And we need to find where that is. Now, if it's been shifted, the axis of symmetry might be somewhere else. It might be, like somewhere over here, or it could be here. And the formula we use to find the axis of symmetry is -b over 2a. So using your formula in standard form, find me the axis of symmetry of this graph. And when they say -b over 2a, they're referring to the standard form that we started this graph with. So we get -8 over 2 times -2, which is -8 over -4, which is 2. Okay, now, in this mystery parabola that we're trying to draw, what we found is that the axis of symmetry, the place that goes through the middle of the graph, x is going to be 2. But there's something else that's really important in a parabola, something called the turning point. And the turning point has an x value of 2, or it'll have an x value of whatever the axis of symmetry is. But we still need to find the y value. So what I say is step 5 is the turning point, and we need a y value to go with the x value of 2 that you've just found. And the way we get that y value is we sub the 2 back into the original equation. So I get -2 and then 2 squared plus 8 times 2 plus 20. So I'm subbing this 2 that I found back in here. Can you find me what the y value is? Can you find me what the y value is? So we get minus 8 plus 16, 8, and then this would be, so can you find, I'm basically saying, can you find me this thing here? And you should get 28, which means that the turning point for this parabola is going to be 228. So it's the point 228. Now, once you've got your 5 steps, you are now ready to draw your parabola. So let me draw this for you. So all you need to draw a parabola is you need a Cartesian plane. So you draw it like that. And then what I do is I put my axis of symmetry down first, because it kind of cuts the graph into 2 halves. So that is x equals 2, which is taken from here. Now what I do is I put dots where all my intercepts are. So we are going to have y equals 20, which is admittedly going to be quite high up here. And then we have 5.74, which is going to be probably like somewhere around here. And then I have minus 1.74, which is probably going to be somewhere around here. And then the turning point is at 28, so it has to be even higher up here. So what I do is I mark out the 2 intercepts, the y-intercept, and then my turning point. And then the last step is I put the shape that I drew through it like this, through my graph. And then I do my labels. So this was going to be 5.74. This is minus 1.74. This was 20. This point was 228. And is there anything else I need to label? Normally we would label the equation. So the equation is G. And that's the 5-step process of how you draw your parabola. Now, I know that took quite a bit of time, but I think it's really helpful to see someone go through the whole 5-step process. And what I'm going to ask you to do for the next part until our break is to do one yourself. So here is the one that I want you to do. I want you to do a 5-step process for that parabola. And I want you, I'll even draw it again because it's a bit unclear. If I give you y equals minus x squared plus 4x minus 3, I want you to go through the 5-step process I just did, and I want you to try and draw a graph like I did using that process. And then while you're drawing, I will take questions from anyone who is feeling a bit unsure or confused. What is represented by the blue dot on the y-axis? That is the y-intercept. So if you look here, y is 20. So here, that's that one over there. Okay. So if there are questions, please repeat step 5. Okay. So when you want to find the turning point is this thing over here. And it has a 2, which is on the axis of symmetry. So that's the 2 comes from step 4. And then when I take 2 and I plug it back into the original equation, I get 28. And together they have my turning point 228. And that's this point up here. So why in the x didn't we divide by minus 1? We didn't because we didn't need to. We were just, the only goal was today is to teach you how to draw parabolas. That's it. So we're going to draw parabolas that are in turning point form now, but for the first one today, it's easier to go with drawing parabolas in standard form. How did I get the y-intercept? To find the y-intercept, you make x equal to 0. So if I look at this next graph, if I follow my 5-step process, my first step is going to be, is it happy or unhappy? And because of this minus sign, I know it's unhappy. Step 2 is to find the y-intercept. I make x naught. And if that's naught and that's naught, this has to be -3. Now, you still need to do 3 more steps, but can you see how the process repeats itself? So the third step is going to be to find the x-intercept. And so we have to make y 0. If you get the 5 steps done, then you can start drawing your graph. Yep, I agree, Lalita. It's y equals -3. That's for the y-intercept. Now, what about the x-intercept? I'd love to hear from someone who thinks they know the answers. I see Lalita has put x is 1 or x is 3. Does anybody else agree with her? Ah, Inga agrees. Okay. Who else agrees? I'm feeling a bit lazy, so I don't know if I should go through all this process, but it looks to me like you are on the right track. This is going to be, what's this? This is going to be minus, minus, minus. So that's going to be over 4 over -2. So -4, yeah. X is 1, yeah. Okay, you guys are right. X is 1 or X is 3. Okay, what about step 4 and 5? Now, can you remember what I said the formula was for the axis of symmetry, the part that folds your graph in half? It was -b over 2a. So, what is that going to be here? It's going to be -4 over 2 times -1. The same thing again, -4 over -2. I get 2, yeah. That's a coincidence. It's not always going to be 2, I promise. So now what I need is I need to know what is the full value of the turning point. So I need to plug that into the original equation, and I want to get a y value there. So where was the original? The original was at the top here. We get -2 squared plus 4 times 2 minus 3. And so I get the point 2, 1. So I want you to draw your parabola now. And what I said was we make our axis of symmetry. So it's a little bit unclear, but we get x is 2, and then we want to make dots for the other intercepts. So we know that there is a x is 1 and x is 3. And we know that our turning point is at 2, 1. So the turning point would be here. And then the y-intercept is -3. So it's going to be down here. And so the shape of my graph is going to be, oopsie daisy, let me redo that, a bit more curvature there. And so then what we do is I'm just going to put my labels in. Sorry, this is not the neatest one in the world, but we get -3 there, we get 1 there, 3 there, and then this point is going to be the point 2, 1, and the graph has the equation like that. Okay, so drawing a parabola from standard form is not so bad. All you need to do is follow the 5-step process. And what you'll notice too is that the axis of symmetry is halfway between the two x-intercepts. So that's also something interesting, that it's always symmetrical. It's like the line that you can fold down. Okay, let me just get a quick little feel from the group. Thumbs up if you feel like you're following what's going on. Thumbs down if you're feeling a bit rushed and overwhelmed. Let's unmute Lisa Kanya. So this will probably be about 5 or 6 marks. Okay. Don't worry, we're going to practice this more after the break. So even if you're not there yet, I'm just getting a feel for, it's just sketches overwhelming me. Okay. Ingo, can I say that the focusing on the 5 steps first and then worrying about the axis of, this is the steps. So you do all this stuff first, you do your working out, then you draw your Cartesian plane and you do your axis of symmetry. Then you make your dots and you put the shape that you chose through those dots. And the last step is you label. Okay, so that's, if you're feeling a bit overwhelmed, don't worry. In the second part of the lesson, we're going to go over this again. All right, everyone, we've been going for a solid half an hour and it's time for a brain break. So we take care of our brains take care of us. And so what I want to do is I want everyone, oh no, let me not go there yet. I want everyone to stand up on their feet and I want you to join me in just unwinding for a second. Oh, wait, let me move my camera's in a different place today. All right, so do something. I like the spinning, whatever makes you feel like your body is. Oh, you get the clicks. And maybe some shoulder rolls. Look out in front of you and just roll those shoulders, then roll them forward. And again, you don't have to do exactly what I'm doing. I'm just kind of guiding you based on what works for me. Let's do some small circles and then big circles. And then change direction, go the other way. And then big ones. Okay, then just do a little stretch with your shoulders. 1. And stretch to the other side. And then just shake your arms up, shake your legs out. So just kick them out a little bit, like you loosening up. And okay, and then let's do some high heart rate stuff. Let's do jumping jacks. So make sure your space is clear, that you don't whack anyone or anything. We're just going to do 20, and the way a jumping jack works is just like that. And let's go. 1, 2, 5, 6, 7, 8. Oh, I'm out of time. And then 3, 2, 1, and we can stop. Okay. And then let's have a fun question. So You can either do the maths 24 question, or you can tell me how many puppies there are in the room. Okay, so there's two choices. You can either do this one for your brain break, or you can solve the maths 24 puzzle. Who feels like they can do it? It feels like that first dog has to be 7. I want to know, what is the final answer? A couple of answers are coming through. So I'm guessing this has to be 3 and 3 and 3 and 3, which means this has to be 6. And what's that going to be equal to? 7 plus 6 is 13. Minus 3 is 10. Plus 6 is going to be 16. And that's it. So I see people get 22, but there's a minus here. So I'm feeling pretty confident that 16 is the correct answer. Okay. Cool. I'm not going to do the maths 24 question today because I think time is short, and I think we all want to, yeah, I know it was a minus, I'm afraid. But I hope that was a nice distraction to get your brains away from graphing for a second. And let's go and do another one. Let me give you one where it isn't. Okay, let's do this one. So before we start trying to draw this graph, what do we notice about this graph compared to the last one? What do we notice that's different? Okay, let's unmute Amanda.
Hi, sir.
Hey, what's different about drawing this graph?
I'm not sure, but I think it's not in a standard form, if I'm not
Yes,
mistaken.
it's not in standard form. It's not in that lovely, neat ax squared plus bx plus c form. It's
Yes,
in the
exactly
turning
my
point
point.
form. Okay. Now, today, what I'm going to show you is that even if it's in turning point form, you can still change it back to standard form. However, once you understand a turning point form well, you don't even have to do this, but I think it's a nice thing to do for today. So let me just show you how I can break this apart. Now, x minus 4 squared is just x minus 4 times x minus 4, and then minus 1 is already there. If I multiply this out, I get x squared minus 4x minus 4x plus 16 minus 1, which then means that this can be written as x squared minus 8x plus 15. So even though this was written in turning point form, and sometimes it's quicker to work straight from turning point, the equivalent graph in standard form would be this. Give me a thumbs up if you understand how I went from the turning point form to standard form. Give me a thumbs down if you have no idea how I did that.
Mr. Ayers, can you please drop down your camera a little bit?
Oh, yeah, sorry. I completely forgot. That's, yeah. Okay, now, there was a question that says, can't you get the turning point straight from the turning point form? You absolutely can. And I'm going to show you at the end. But just for the next 5 minutes, can we please go through the 5-step process for drawing this parabola that I have just given you? And what I'm going to do is I'm just going to focus on the standard form first, and then I'll talk to you about the turning point form afterwards. Okay, so I want you to complete the 5 steps for me, and then as you do it, you can put your answer in the chat. And then we're going to draw this graph, and then I'll talk a bit more about stuff. So the 16 lost me on the second step. Okay. The -4 times -4 must be plus 16. So that's the thing there. The x times x must be the x squared. So if I lost you here, notice how this times this must be x squared. And then like this times this must be that. That times that must be that. And then let's say like -4 times -4 is the plus 16. So step 1 is this is a happy graph because there is a 1 in front. And then step 2, the y-intercept is 15. Because when you make x 0, it knocks out all the other bits and you're just left with this one. Pleasure, Lolita. That's why I'm here. How do we find the x-intercepts? Now you could use the quadratic formula, or if you see how to, we could factorize it. And Ovayo says x is 5 and x is 3. So does Andiswa. So I agree with you. X is 3 or x is 5. Now I want you to get me steps 4 and 5 and then to draw the graph for me. And I want to give you a bit more time. I don't want to rush you. So go ahead and do that, but you can carry on giving me answers in the chat.
Keep going, guys. We've got this.
Absolutely. Absolutely. So for the axis of symmetry, you need to use the formula minus b over 2a. So you should have got 4 as your axis of symmetry. Now, what is my y value going to be that goes with that? Now, I could put it back into I could put it back into the top original or the standard form. They'll both work. It looks to me like it might be quicker to put it into this one, but they're the same thing. And you should get, if you put it into that one, it's a bit easier. You actually get -1. Yeah. Okay, now for all my students who are feeling a bit intimidated by drawing the graph, think about this. Step 1 is you draw your XY plane. Now you look at this at the spacing and you go, my axis of symmetry is 4. So let's give it space, like 1, 2, 3, 4. And it's going to be over here. Okay, so x is 4. Now, what I like to do, you don't have to do it like this, but I found it useful, is I try and put dots for the places I'm going to draw through. And what are the places I'm going to draw through? Y is 15, x is 3, x is 5. So I think there'll be a dot here and a dot here for the x-intercepts. There will also be a y-intercept of 15, which is here, and then a turning point, which is at 4 minus 1. So it's just going to be dropping down a bit here. Yes, Amanda, I'd love to hear a question. What can I help you with?
Say I'm getting lost here.
Okay.
For the turning point, to find the y-intercept.
Okay.
I don't know
Yeah.
how to find it,
Okay,
because
let
I
me
got
help
4.
you. You used
Because
4.
Yes, I got 4. I said x is equal to negative b divided by 2a. Then to find the y, I don't know how to, to do it. I'm getting lost.
Okay. There's 2 ways you can do it. The one way is to put it into the original, and then the other way is to put it into the standard form one. They should both give you the same answer. So on the bottom here, can you see when it's red, there's a 4. If you go 4 minus 4, do you agree that you get 0? Okay, maybe I've lost you there. So 4 minus 4 is 0. 0 squared is nothing. And then 0 minus 1 is minus 1. So that's using this one. If I put it into the standard form here, it will also give you that, because you get 16 minus 32, which is minus 16, plus 15, which is minus 1. And that's where the minus 1 comes from here.
Oh, thank you,
Does that
sir.
help?
Thank you so much. Yes.
Pleasure. Okay, now last step is it's a happy graph. So I put my steps, I put my smiling face through here. It should be a bit. And then I label my graph with its points. So it's going to be 5, 3, 15. And then here is going to be 4 minus 1. And the equation of the graph was f. So drawing the graph from standard form has been done again. Now, what I want to point out is that there was a student who said, can't you get the turning point in step 1? And you actually can, because it's in the turning point form. And so when a graph is in the turning point form, like we discussed at the beginning of the lesson today, minus PQ will give you the turning point. So if you look at this thing at the moment, what is minus PQ? It's just going to be minus 4 and minus 1. And so you can get the turning point straight from the graph. But I just thought for today, I'll show you that you can also work it out using the long way. And as we get more comfortable with the turning point form, we can also use that. It was you, Inga. Oh, does it make sense now, Inga, that we can get it using the short way? But for today, I just wanted to focus on this. So can you do the first step using the quadratic formula? When you say first step, I think you mean the x-intercept using the quadratic formula. Is that what you mean, Ayanda? Okay, I want to squeeze in one more of these today. I know it's a bit of a push, but I feel like we can do it. So I don't know if there'll be enough time to finish it, but I want you to at least start. Yes, you can absolutely use the quadratic formula. So here is a parabola. I want you to draw it using the 5-step process I just showed you. We won't have time to draw the graph, but we can definitely get most of the working done. So see if you can do that in the time that remains. So is it always advisable to have the asymptote? Lalita, it's not an asymptote, it's called an axis of symmetry, and it cuts the parabola in half. So would you have these steps apply to the graph because you're busy with hyperbola? We're going to do hyperbolas next week, Annie, and hyperbolas have similar steps. You put the asymptotes in first, but I need to talk to you about them separately. Okay, I don't want to confuse the issue for today. I'll actually show you with this one, there's actually two ways you can do it. The one way is to do it leaving it in turning point form, and the other way is to break it down. So it's up to you guys, you know, what you want to do. I'll show you both. But if you were breaking it down, you would have to first multiply out this bit and that can be a little bit tricky. But I'll help you with it because of time. Okay, so that would be the equivalent one to that. So see how I multiplied it out? And notice how when this negative sign came in, it changed everything's sign around. Yes, Inga, exactly. So Inga is asking me if I wanted to get the turning point straight from here. Inga, the turning point would actually be 5, 4. So it's minus P, it's minus whatever this is. So it's going to be 5 and then 4. And you'll see that if you go through the 5 steps, you will get that here too. So I'm going to say step 1, this is an unhappy graph. Step 2, what's my y-intercept? Yep, Mbali and Zanele, it's going to be minus 21. What's my x-intercept going to be? So we have to make, or I could have also done it just to show, I don't want to confuse anyone, but it's not wrong. It's not wrong to write that equal to 0, because remember that this thing over here and this thing over here are the same thing. It's just two different ways of writing the same thing. So whichever one you think is easier, you can solve. What are my x-intercepts going to be? Pabalo has said 7 and 3. Does anyone agree with 7 and 3? Annie, yes, the y-intercept is always the last value in standard form, yeah. Chuma agrees, x is 3, x is 7. Okay, and I can see that it is in fact the correct answer. Now, what is my axis of symmetry? Now, again, I've kind of cheated because it's in turning point form. You can see already, but let's just see that it does work. What would my axis of symmetry and turning point be? So it does appear to be 5. Yep. And what's my turning point going to be then? Or what's the y value going to be that goes with the 5? Okay, and I suppose some of you can kind of sneaky see this. You can see it's going to be 5, 4. Now, we're not going to have time to draw this tonight, but my goal for tonight was just to show you that parabolas can be written in 2 different forms. And they, depending on what's easier for you, you should work with whatever form is easier for you. The drawing of the parabola can be divided up into 5 steps. And if you practice those 5 steps and you practice drawing the graphs, it's actually not so bad.